right, students, we are going to do some statistics. Today, we're going to be looking at the t-test. The t-test tells you if the average of two different samples is the same. So here I have the heights in centimeters of students in my class. I have the female students and the male students, and I want to know if there is a statistically significant difference in height between the two samples. Now, in order to run a t-test, you have to have numbers that are measurements. You can't have a count like how many freshmen ate pepperoni pizza versus sausage. You have to have a number of a measurement number. You also have to have your two varieties here have to have the same number of samples. If I had more male than female students this year, I would have to delete a couple of the males, and it's important that you choose those at random so you don't affect your samples. Okay, so I'm going to just click on any empty box, and I am going to go to insert because I'm inserting something, go to function because it's a function, and then down to statistics because that's what we're doing. We're going to go down and find the one that says t-test. The t-test asks for four things. The first two things are the range. So the first thing I'm going to do is highlight the heights of all of my female students. So now I've told it, here's one sample group you're going to look at. I'll hit a comma to separate it. And now I'm going to highlight the second range, the male students. Oh, oops. And I'll do it again because it's screwed up. Okay, now I'm going to hit a comma so that it knows that that's the second range. The next thing is asking for the tails. A bell curve has a mean in the middle and a tail on each end. If we were comparing something like the height or the weight of people versus elephants, we need a one-tailed test because elephants have to be bigger than people, unless it's a very small elephant or a very large person. But since this height could really go either way, we're going to put 2 for the number of tails. And then we have to do the type. For the type, you're going to select type 2, which is the type of equal variance. If you're curious about why I chose that, I highly recommend taking a statistics class. In college, I loved it. I had so much fun in that class. It was definitely my favorite math class. Okay, now I'm going to hit enter and look, I have a number. Yay! Great. What does that mean? Well, this number is something called your p-value. And this is the percentage of the time that the null hypothesis is true. So if you get so it's a percentage. So the biggest number you get is 1. That never happens. But if you got a 1, it would mean your null hypothesis is 100% true. The numbers are the same. There's no difference. So scientists and statisticians had to agree on what's the cutoff. What's an acceptable amount of error? And they said if 95% of the time you can reject the null hypothesis, then that means your stuff is legit. So if your p-value is less than 0.05, then you have statistical significance. And it looks like here we have a p-value of 0.00006. So we definitely have significance. So you can say there is a statistically significant difference between the means of the male and female students' heights. And then you would write that you did a t-test and that the p-value was equal to 0.12346. Okay, so that is how you perform the t-test, and that is how you would write it up in your results.